November 5th, 2018. 11 billion miles from where you are sitting right now, a 41-year-old machine the size of a small car goes silent for exactly 25 seconds. Not a system failure, not a malfunction. For 25 seconds, every single instrument on NASA's Voyager 2 spacecraft reads 0. No solar wind, no particles, no pressure from the sun at all. And then, just as suddenly, the readings come back. But they are not the readings anyone expected, and they are readings from a place no human-made object has any right to be. In that 25-second gap, Voyager 2 didn't just cross a line in space, it fell through a hole in the wall of our solar system. And what it found on the other side is still being argued about by scientists who cannot fully explain it. This is the story of how NASA quietly confirmed something almost nobody outside of a physics lab has heard about, that the bubble protecting our entire solar system isn't sealed. It's cracked. And through that crack, something is leaking, both ways. To understand why this matters, you have to go back to a summer morning in 1977 when a rocket lifted off from Cape Canaveral carrying a spacecraft that nobody, not even the engineers who built it, believed would still be working half a century later. Voyager 2 launched on August 20th, 1977, 16 days before its twin sibling Voyager 1. Both were built for a single grand purpose: to use a rare planetary alignment that happens only once every 175 years to slingshot past Jupiter, Saturn, Uranus, and Neptune in one continuous tour, using each planet's gravity to fling the spacecraft farther into the dark. Voyager 2 remains, to this day, the only spacecraft in human history to have visited all 4 of the outer giant planets up close. It photographed the storms of Jupiter, threaded the icy rings of Saturn, discovered new moons around Uranus, and sent back the first, only close-up images of Neptune's swirling blue atmosphere that humanity has ever seen. By the time it finished that tour in 1989, most people assumed its job was done. It wasn't. It was only getting started. Because after Neptune, Voyager 2 kept going. It had no more planets to visit, no more moons to photograph, but it had something bigger ahead of it, the edge of the sun's influence itself. Here is something most people never think about. The sun is not just a source of light and heat. It's a machine that constantly exhales. Every second it throws out a stream of charged particles called the solar wind, blasting outward in every direction, at speeds up to 1 million miles an hour. That solar wind inflates a colossal invisible bubble around our entire solar system called the heliosphere. Every planet you know, every moon, every asteroid, all of it sits inside this bubble like a ship inside a bottle. The heliosphere is what shields us from the harshest radiation of the galaxy. The high-energy cosmic rays that come screaming in from exploded stars and black holes light years away. Without it, life on Earth as we know it might not exist. And for decades, scientists pictured this bubble as something clean and simple, a sharp, solid boundary like the skin of a balloon, with the sun's influence on one side and true interstellar space on the other. Voyager 2 was about to prove that picture wrong. By the early 2010s, engineers back on Earth were watching Voyager 2's instruments with growing anticipation. Its sister ship, Voyager 1, had already crossed into interstellar space back in August 2012, becoming the first human-made object ever to leave the solar system. But Voyager 1 exited through a completely different part of the bubble, through what scientists call the nose, the very front of the heliosphere, the direction it's moving through the galaxy. Voyager 2 was heading out through the side, through the flank of the bubble, into a region nobody had ever sampled directly before. Scientists knew this crossing would be different, they just didn't know how different. On November 5th, 2018, at a distance of roughly 11 billion miles from Earth, nearly 18 billion kilometers, more than 3 times farther out than Pluto's orbit, Voyager 2's instruments detected the moment. The plasma science instrument, which measures the density and temperature of charged particles around the spacecraft, recorded a sudden and dramatic plunge in the outward flow of solar wind particles. At the exact same time, cosmic ray detectors on board registered a spike in high-energy particles flooding in from interstellar space, the kind of radiation that the heliosphere normally blocks. It was as if a curtain had been pulled back. One moment, Voyager 2 was bathed in particles from our own sun. The next, it was standing fully exposed in the open radiation of the galaxy itself. Mission scientists confirmed it. Voyager 2 had become only the second spacecraft in history to cross the heliopause and enter true interstellar space. That alone would have been history-making. But it's what came a year later, when scientists finally finished analyzing the full data set, that turned this from a milestone into a mystery. In November 2019, exactly 1 year after the crossing, NASA released 5 separate scientific papers in the journal Nature Astronomy, each one focused on data from a different instrument aboard Voyager 2. And buried inside those 5 papers was a detail that changed how scientists think about the boundary of our entire solar system. One of Voyager 2's particle detectors picked up something strange. A steady, measurable trickle of particles from inside the heliosphere slipping outward through the boundary into interstellar space. Not a flood, not a rupture. A trickle, persistent, ongoing like water finding its way through a seam that was never supposed to be there. Scientists studying the data used a phrase that sounds almost too simple for something this profound. They said that if the heliosphere is like a ship sailing through the galaxy, then the hull of that ship is somewhat leaky. Material from inside our solar system is escaping. And material from outside, from true interstellar space, has been found seeping in the other direction as well. The wall protecting our entire solar system, the wall scientists once pictured as smooth and sealed, has holes in it. It's porous. It's cracked. And here's the part that should genuinely unsettle you. Nobody fully knows why. Voyager 1 had detected hints of this leakiness years earlier at the front of the bubble, but in the opposite direction, interstellar particles streaming inward like roots pushing through rock. Voyager 2, sampling a completely different location on the flank of the heliosphere, found leaking happening in the outward direction instead. Two spacecraft, two totally different regions of the boundary, separated by billions of miles and years of time, both found the same fundamental truth. This is not a sealed border. Scientists now believe the leakiness might not be rare or accidental at all. It might be a permanent structural feature of how the heliosphere interacts with the rest of the galaxy. Dr. Don Gurnett of the University of Iowa, one of the lead scientists on the plasma wave instrument team, put it plainly when the results came out. The old assumption that the solar wind simply fades away gradually as you travel outward is, in his words, simply not true. There's a real measurable boundary out there. It is just not the clean, sealed boundary anyone expected. Voyager 2's magnetic field instrument added another twist to the mystery. Just beyond the heliopause, in the region that should belong entirely to interstellar space, the magnetic field lines were found running parallel to the magnetic field inside our own heliosphere. With Voyager 1, scientists had only one sample of this and couldn't be sure if it was a coincidence. Voyager 2 confirmed it wasn't. Somehow, the magnetic environment of our solar system appears to be leaking its influence, or blending with the surrounding interstellar magnetic field, in ways physics models did not predict. Meanwhile, Voyager 2's plasma wave instrument, essentially able to listen to the density of charged particles around the spacecraft by picking up their natural oscillations, detected something else entirely unexpected. As Voyager 2 pushed further from the heliopause into deep interstellar space, the plasma density kept climbing, higher and higher, well beyond what anyone had modeled. And strangely, this matched almost exactly what Voyager 1 had measured years earlier and hundreds of millions of miles away, at a completely different point along the boundary. Two independent spacecraft in two independent locations, confirming that the region just outside our solar system is denser, stranger, and more structured than any model had predicted. Stop and actually sit with that for a second. Two machines built in the 1970s, using computers with less processing power than a modern calculator, running on plutonium batteries that lose a tiny fraction of their power every single year, are still transmitting data from a region of space so far away that a radio signal traveling at the literal speed of light takes over 16 hours just to reach Voyager 2, and over 20 hours to reach Voyager 1. These signals were sent using antennas the size of a coffee cup, and NASA is catching them using satellite dishes here on Earth wide enough to swallow a football field, listening for whispers fainter than a cell phone signal from the surface of Pluto. And what those whispers are telling us is that everything we assumed about the wall protecting our solar system was incomplete. Here's why this actually matters, far beyond scientific curiosity. The heliosphere isn't just an abstract bubble in a textbook diagram. It is the reason cosmic radiation from distant supernovae and black holes doesn't constantly bombard Earth at full intensity. It's part of the reason life had room to evolve here the way it did. If that protective bubble has structural leaks, gaps that scientists still cannot fully explain, then understanding exactly how, where, and why those leaks form isn't optional. It's essential. It could reshape how we think about planetary habitability across the galaxy, because if our own sun's shield is porous, then the shields around other stars, protecting other potentially habitable worlds, are almost certainly porous too. Every exoplanet astronomers are excited about, every distant world being scanned for signs of life, sits inside its own version of this same imperfect bubble. Suddenly, the question of, is this planet protected enough to support life, becomes far more complicated than scientists assumed even 5 years ago. There's also a much more immediate human reason this matters. Voyager 2 is still out there, still transmitting. Still, somehow, sending back usable scientific data almost 50 years after launch, running on a power source that NASA engineers have had to carefully ration, shutting down non-essential instruments one by one just to keep the spacecraft alive a little longer. In 2020, the massive radio dish in Australia used to communicate with Voyager 2 went offline for repairs for almost a year. And for months, humanity could send commands to the spacecraft, but couldn't hear anything back. Engineers were quite literally shouting into the void, hoping their 40-year-old machine was still listening. It was when contact was restored, Voyager 2 responded exactly as commanded, still functioning, still billions of miles past the edge of everything we call home. NASA now projects that Voyager 2 will likely lose the power to run any scientific instrument sometime in the coming years, and after that, it will drift on in silence, forever, carrying its golden record, an actual physical phonograph disc loaded with images, sounds, greetings in 55 languages, and music from Earth, meant for any intelligence anywhere that might one day find it, long after every human alive today is gone. So when someone tells you NASA confirmed a crack in the edge of our solar system, understand what that really means. It's not a crack the way you'd imagine one in a windshield or a wall. It's something far stranger, and in some ways, far more important. It means the boundary separating our entire solar system from the rest of the galaxy is not a solid seal, but a living, breathing, leaking membrane, one that scientists are only beginning to understand, using data being fed to them right now by a spacecraft older than most of their own careers. It means the thing standing between Earth and the raw radiation of deep space has holes in it that nobody predicted and nobody can yet fully explain. And it means that somewhere out there, past the edge of everything familiar, an old machine humanity built decades ago is still working, still listening, still sending its last whispers home through a crack in the wall of our own solar system, waiting for someone, someday, to fully understand what it found. If this story pulled you in, imagine what else is still out there waiting to be discovered. Subscribe now so you never miss the next mystery from the edge of the universe.